When a material is loaded, it deforms. If the material returns to its original shape after the load is removed, the deformation is called elastic. If a permanent change remains, it is called plastic deformation. This difference is fundamental in engineering because most components are designed to operate in the elastic region and avoid permanent deformation during service. Deformation is the change in shape, size, or dimensions of a material due to an applied load. When forces act on a component, its length, thickness, or geometry may change. Deformation can be temporary or permanent depending on the magnitude of the applied stress and the material's mechanical properties. Understanding deformation is the first step in predicting structural behavior. Elastic deformation is fully recoverable. When the load is removed, the material returns to its original dimensions. This behavior occurs below the yield strength and follows Hooke's law, where stress is proportional to strain. Springs, shafts, bridges, and machine components are typically designed to operate within this region to ensure reliability and repeatable performance. Plastic deformation occurs when stress exceeds the yield strength of a material. In this region, permanent deformation remains even after the load is removed. Examples include a bent paperclip or a dented car panel. Although undesirable in most structural applications, plastic deformation is intentionally used in manufacturing processes such as forging, rolling, stamping, and extrusion. The stress-strain curve clearly separates elastic and plastic behavior. In the elastic region, deformation is recoverable and Hooke's law is valid. At the yield point, permanent deformation begins. Beyond this point, the material enters the plastic region, where strain continues to increase and deformation becomes irreversible. Yield strength therefore acts as the boundary between safe elastic behavior and permanent plastic deformation. Understanding elastic and plastic deformation is critical for engineering design. Components such as shafts, bolts, springs, and structures are designed to remain elastic during operation. However, plastic deformation is intentionally used in manufacturing to permanently shape materials. Engineers must know when deformation should be avoided and when it can be used to achieve a desired outcome. Let's summarize. Elastic deformation is temporary and fully recoverable, while plastic deformation is permanent and remains after unloading. The transition between these behaviors occurs at the yield strength. Good engineering design keeps operating stresses within the elastic region, ensuring components remain safe, reliable, and functional throughout their service life. If you found this video useful, please like, subscribe, and follow the Mechanical Engineering Basics series. Thanks for watching, and I'll see you in the next lesson.